Hi, hello, good evening, everyone. I welcome to you all to the another amazing session on Basic Maths Lecture 4. Okay, so let me share my screen here. Yes, so I'm sharing my entire screen here so that you can able to see writing board. Okay, so before starting the lecture, let me introduce myself to you. My name is Ramesh Babu. I have completed my BTech from BB80 Nambur, which is located in Guntur district of Andhra Pradesh. Okay, so let me check whether it is live or not. Yes, we are live. Yes, we are live. So is my voice is audible and is it clear? Audio and everything. Please respond in chat box so that I can see here. Yes, Kavin, hi. Clear. Everything is clear. Audio is perfect or not? Audio, screen, everything is perfect, right? So I can see two people here. Yes, everything is good. Okay. Hi. Yes, 1 minute. I'll make it clear for you. Screen. So last class is what we have discussed. Once see here. So basic maths lecture one. We started with the inequalities. So what is equation and what is inequality? Difference we have seen here. So any expression having equals to sign is called equation, and an expression with inequality sign is called an inequation. So and the interval and its representation also we have seen how to represent open interval, closed interval, and semi-open, semi-closed. Okay. So operations on intervals, union operation as well as intersection operation also we have seen, and rules for solving inequalities. After that, Wavy curve method for solving inequalities also we have completed. Then rational inequalities. What is the procedure to solve rational inequalities we have completed, and see these note points. See these note points. These two note points are very important while cross multiplying quadratic equation in an inequality. Okay, based on these note points, we will do one question right now. So remember these two note points carefully. Based on these two note points, we will do one PYQ now. If A is greater than 0 and D is less than 0, quadratic equation is always positive. And if A is less than 0 and D less than 0, quadratic equation is always negative. Okay, just remember that note point. So this is what we have seen in basic maths lecture 1 and lecture 2. So basic maths lecture 3, we have started logarithms. So what is the logarithm definition, and what is the input and output of a logarithm? Next, domain and range of a logarithm also we have seen, and properties of logarithms. Okay, and equations of log also we have seen here. So what is the answer for this homework question? Can anyone just tell me what values of x will satisfy this logarithmic equation? What value of x will satisfy this logarithmic equation? Homework question I have given in the previous session. Okay, so what is the answer for this? Let me tell you the answer for this question. X belongs to 5. What is the meaning of x belongs to 5? No value of x is satisfying this logarithmic equation. Okay, x belongs to 5. No solution. No solution for this logarithmic equation. Okay. No solution for this logarithmic equation. Yes. So this is a practice question, Kavin. See, this is a practice question I have given to you. Okay, you have to find the answer. So no solution for this. Okay, so let us move to the next topic for today's, which is graph of logarithm and logarithmic inequalities. We need to discuss in today's class. So before going to the graph of log, kindly do, sir. Okay, let me solve this homework question for you. So solution for this is, 1 minute. Solution for this question is, what's happening here? 1 minute. Let me put it again here. So how to solve this homework question? Let's see here. Solution is a log of, this is x root of 5. X root of 5 is nothing but 5 power 1 by x to the base 5 plus 125 equals to log 6 base 5. So how we can write 1? 1 we can write it as log 5 base 1 we can write now. We can write 1 as log 5 base 5. Okay. Plus, what is, how we can write 1 by 2x? 1 by 2x we can write it as log 5 base 5 to the power 1 by 2x. Okay. So now what is the formula for log m plus log n? Log m plus log n formula is log mn. Okay. So see here, log of 5 power 1 by x plus 125 to the base 5 equals to log m plus log n formula is log mn. So 6 into 5, 30 into 5 power 1 by 2x to the base 5. So by comparing on both sides, this part alone, by comparing this part alone on both sides, so we have 5 power 1 by x plus 125 equals to 30 times 5 power 1 by 2x. Okay, clear up to here? Now we need to assume 5 power 1 by x or 5 power 1 by 2x as t. So if you assume 5 power 1 by x as t, by squaring on both sides there is no use. Okay, so assume 5 power 1 by x as t. Let 5 power 1 by x 1 by 2x equals to t. Now by squaring on both sides, what is the 5 power 1 by x? By squaring on both sides, 5 power 1 by x will become 2 square, right? 5 power 1 by x will become t square. Why? Because if we squaring on both sides, this 2 and 2 will be cancelled out and t square will remain. Okay, so 5 power 1 by x is t square. In place of 5 power 1 by x, I am writing t square, and here 125. So here 30 times 5 power 1 by 2x, we assumed it as a t, so 30t. Now this is a t square minus 30t plus 125. So what are the values of t here? What are the values of t? How we can factorize this quadratic equation? Once tell me. So we need to split the middle term. Here we can have 5 2's and 5 5's. 25 and 5 we can split now. Middle term we can split it into minus 25t minus 5t plus 125 equals to 0. So this is a t minus 25 t of t minus 25 minus 5 of t minus 25. So t minus 25 into t minus 5 equals to 0. So we got t equals to either 5 or 25. Okay, clear till now? So t equals to 5 or t equals to 25. If we substitute here 5 power 1 by 2x equals to 5 power 1. 1 by 2x equals to 1. So x equals to 1 by 2. Okay. One value of x equals to 1 by 2. One more value is 5 power 1 by 2x equals to 5 square. So 1 by 2x equals to 2 and x equals to 1 by 4. Okay. So x equals to 1 by 2 and x equals to 1 by 4. We got two values. But if we substitute this x equals to 1 by 2 and x equals to 1 by 4 in the given equation. Okay. If we substitute these x equal to 1 by 2 and x equal to 1 by 4 in the given equation, x the root of 5. X the root of 5. If you substitute here, in place of x, if you substitute 1 by 2, see like this, if you have seen any expression before, okay, we have seen square root of 5, we have seen root 5, we have seen cube root of 5 also we have seen, fourth root of 5 also we have seen. Have we ever seen this 1 by 2 root 5 and 1 by 4 root 5? Once tell me, have you ever seen this half root 5 and 1 by 4th root 5? This is not allowed in such. Okay. While writing these such, fractional power is not allowed. Okay. This fractional power is not allowed while writing such. Okay. 5 power 1 by x, when you can write 5 power 1 by x root of 5, okay. X root of 5, which is 5 power 1 by x. If we place x as 1 by 2 here, this is not satisfying, no. It is not allowed, okay. While writing such fractional powers, we not to put, okay. Those, so natural numbers only we can give while writing such. So this is not valid. So x equals to 1 by 2 and x equals to 1 by 4, even though we got x equals to 1 by 2 and x equal to 1 by 4, these are the not valid answers, okay. It is not valid, it is not valid, okay. While writing such, only natural numbers we can give as input here. Here we can give only natural numbers as input. We cannot give fractional powers here. Okay. We cannot write a fractional part here. This is not valid. Okay. So clear? Homework question, it is clear or not? Yes, I hope it is clear. So shall we move to the next topic? Tell me in the chat box. Shall we move to the next topic here? Yes, we can move to the next topic. Okay. So what are the commonly used bases in logarithm? What are the commonly used base? So what are the commonly used bases in logarithm? Commonly used base. So what are the commonly used base in logarithm? Can anyone tell me what are the commonly used base? Which base you have seen while writing logarithm? 10 and E. Yes, of course. 10 and E are the commonly used bases. Okay. So logarithm with base 10 and logarithm with base E. So what we will call this logarithm with base 10? What do we call this logarithm with base 10? Logarithm with the base 10 is called common logarithm. Okay. So logarithm with the base 10 is called common logarithm. Okay. And logarithm with base E is called, what we will call this logarithm with base E? Logarithm with base E is called a natural logarithm. Okay. So logarithm with base 10 is called common logarithm and logarithm with base E is called natural logarithm. So what is the default base if they didn't mention anything. If they didn't mention anything, by default we will consider 10 as the by default we will consider 10 as the default base. Okay. So if they didn't mention anything, by default we will consider 10 as the base. Okay. If they didn't mention any base in question, by default we will take 10 as the default base. And what is E is called here? Here E is called Euler's number. Okay. Here E is called Euler's number. And what is the value of E? Value of E is 2.71 approximately. So approximately Euler's numbers value is equals to 2.71. So these are the commonly used base in logarithms. One is the base 10, another one is the base with E. So logarithm with the base 10 is called common logarithm, and logarithm with the base E is called natural logarithm, where E is called Euler's number, whose approximate value is 2.71. Okay, clear? So logarithm with the base x, okay, sorry, with base E also can be written as, so log x with the base E can also be written as simply ln x. Okay, so this is very important. Okay, logarithm with the base E, shortly we can write it as ln x. Okay, log x with base E, shortly we can write it as ln x. Ln x we can write it shortly. Okay, clear till now? So 10 and E are the commonly used base, and log x with base E we can write it as ln x. Okay, clear? So now we will see the graph of log x. So graph of log x we will see now. What is the graph of log x? Graph of logarithm. So graph of logarithm. What is the graph of logarithm? How it will be? Tell me how graph of logarithm will be, whether it is increasing function or it is a decreasing function. How the graph of logarithm will be, whether it is increasing function or a decreasing function. Once tell me in chat box so that I can see here. Once tell me whether it is increasing function or a decreasing function. Logarithm, graph of logarithm, how it will be? So here we have two cases, right? Here we have two cases for base. What are the two cases for the base? Base of a logarithm should be, base of a logarithm should be greater than 0 as well as not equals to 1. This is a condition for base. What is the condition for base? Base should be greater than 0 and base should not be equals to 1. This is a condition for base of a logarithm. Okay. So two cases we will have. First case is base lying between 0 and 1. What is the first case here? Base lying between 0 and 1. This is the first case. And one more case is, what is the one more case? Base greater than 1. Okay, base greater than 1 and base lying between 0 and 1. Base less than 1, base lying between 0 and 1 and base is greater than 1. Yes, range of log x is from minus infinity to plus infinity. Sekuntala BZ. Yes. Range of logarithm is from minus infinity to plus infinity. Okay, any doubts in that? Graph of logarithm, if base is lying between 0 and 1, you'll get a decreasing graph, and base greater than 1, you'll get increasing graph. Okay. So what is the behavior of the logarithm if base is lying between 0 and 1? It behaves as a decreasing graph. It behaves as a decreasing graph. It behaves as a decreasing graph, and base greater than 1, it behaves as a increasing graph. It behaves as a increasing graph. Okay, if base lying between 0 and 1, graph of logarithm is a decreasing function, and if base is greater than 1, graph of logarithm is increasing graph. For example, consider a base which is lying between 0 and 1. Tell me a number between 0 and 1. Tell me any number between 0 and 1. See, domain and logarithm we have completed in last class itself. Okay, domain and logarithm we have completed in last class itself. Domain is from minus infinity to plus infinity. Sorry, domain is we can give only positive values as input for the logarithm. Okay, domain is from 0 to infinity and range is from minus infinity to infinity. Now I will show the graph of this logarithm so that you will get an idea how the range of a graph is from minus infinity to plus infinity. Okay, still any doubts here? So tell me any number between 0 and 1. Let us consider logarithm with base 1 by 2 here in this first case. Second case we will consider log x with base 2. Okay, first case we will consider log x with base 1 by 2, and second case is log x with base 2. Okay, log x with base 2. So in first case we will get a decreasing graph. So suppose this is y-axis and this is x-axis. Graph of logarithm with base lying between 0 and 1 by 2 will be somewhat like this. Okay, this is the graph. As x is increasing, as x increases, y decreases. Okay, if x value is increasing, y value will be decreasing, so that it is a decreasing function. If base is greater than 1, if base is greater than 1, logarithm graph will be increasing graph. Okay, so it will be like this logarithm graph. If base is greater than 1, this is the graph, and if base is lying between 0 and 1, this is the graph. So this is a decreasing function as when this is increasing function. Increasing function and decreasing function. Okay, clear? Is it clear? If base is lying between 0 and 1, okay, logarithm will behave as a decreasing function, and if base is greater than 1, logarithm will behave as a increasing function. It will help in solving inequalities. Okay, so it will help in solving inequalities. So graph of logarithm also completed. Okay, so today commonly used base and graph of logarithm we have seen. Base lying between 0 and 1, base greater than 1. Okay, if there is a time I'll try to show it in Desmos for you. Hardly it will take 5 minutes to see the graph of logarithm. Okay, base between 0 and 1, base greater than 1. Just remember these 2 points: base 0 to 1 decreasing graph, and base greater than 1 increasing graph. Okay, so one note point you have to note down here. One note point you have to note down here. What is that note point? What is that note point? If we apply, if we apply, if we apply decreasing function, so if we apply decreasing function, if we apply decreasing function for an inequality, if we apply decreasing function for an inequality, sign of inequality will be changed. Okay, sign of inequality, sign of inequality will be changed. Okay, So if we apply decreasing function for an inequality, sign of the logarithm will be changed. Okay, if we apply decreasing function for an inequality, sign of the inequality will be changed. So this will help while solving logarithmic inequalities. Okay, this will help while solving logarithmic inequalities. So up to here, is it clear? Once if you have any doubts, tell me in chat box. Up till now, it is clear or not? Till now, it is clear. Is it clear till now? Yes, I hope it is clear. So shall we move to the next topic here? One second. Shall we move to the next topic? Once tell me in chat box. Waiting for your replies. Yes. Once tell me in chat box so that we can go to the next topic here. Yes, 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 yes. Reply fastly in chat box. Yes, yes. We can go to the next topic. So next topic is logarithmic inequalities. Okay. What is the next topic? Next topic is logarithmic inequalities. Next topic here, we are going to discuss logarithmic inequalities. Logarithmic. So logarithmic inequalities. What are the logarithmic inequalities here? Once tell me what is the logarithmic inequality? What is the logarithmic inequality? Tell me in chat box. What is meant by logarithmic inequality? Can anyone tell me in chat box what is logarithmic inequality? Logarithmic inequality, yes. So if inequality expression consists of a logarithm, it is called a logarithmic inequality. Okay. So if an inequality expression consists of a logarithm, if an inequality expression consists of a logarithm, it is called a logarithmic inequality. Now, how to solve logarithmic inequalities? How to solve these logarithmic inequalities? So, concept is very simple. Concept is very simple here. What is the concept? What is the concept here? If base is lying between 0 and 1, if base is lying between 0 and 1, if base is lying between 0 and 1, change the sign of the inequality. Okay. If base is lying between 0 and 1, change the sign of inequality. Change the sign of inequality. Okay. If base is lying between 0 and 1, change the sign of inequality. If base is greater than 1, if base is greater than 1, no need to you change. Okay. If base is greater than 1, no need to change the sign of the inequality. So same sign of the inequality we will put. Okay. If base is lying between 0 and 1, just change the sign of the inequality. If base is greater than 1, same sign will be there. Okay. Already we have seen rules while solving inequalities. What are the rules we have seen while solving inequalities? If we multiply or divide both sides of the inequality with a negative sign, we are changing sign of the inequality, right? Yes, we are changing the sign of inequality if we multiply both sides or if we divide both sides with a negative sign. Similarly, if base is between 0 and 1, graph is a decreasing function. No, graph is a decreasing function. If base lies between 0 and 1, graph of logarithm is a decreasing function. And what is the note point we have discussed here? if we apply decreasing function for an inequality, sign of the inequality will be changed. Okay, so sign of the inequality will be changed. By applying it will be changed. By removing also it will be changed. Okay. Logarithmic inequality, if base lying between 0 and 1, change the sign. If base is greater than 1, no need to change the sign, same sign will be there. Same sign will be there. Okay. So for example, here itself we can see the example. So here, for example, so base lying between 0 and 1, right? So suppose log x base 1 by 2 is greater than 3. How to solve this logarithmic inequality? Tell me how to solve this logarithmic inequality. And one more is for base, one more example for base greater than 1. So log x base 2 greater than 3. Okay, how to solve this expression and how to solve this expression. Once tell me how to solve these two expressions. Log with the base 1 by 2 greater than 3 and log x with the base 2 greater than 3. So what I have told you here, if base is lying between 0 and 1, change the sign of the inequality. So what is the exponential form of this logarithm? What is the exponential form for this logarithm? Exponential form for this logarithm is x. X will write here, and base will be same base. Okay, x will be left side and base will be base, and 3 will go to the power. So change in sign of the inequality, greater than will become less than. Okay. So while writing exponential form for this logarithm, greater than becomes less than. So for this one, if base is greater than 1, what is the exponential form of this? Left side it is x and right side it is 2q, and greater than will be greater than only. Okay. So for base greater than 1, same sign of inequality, and base lying between 0 and 1, change the sign of inequality. So only we have changed here greater than to less than. So with one example we can see this why we are changing sign of inequality if base lying between 0 and 1, and why we are not changing the sign of inequality if base is greater than 1. Consider one example, 4 is less than 8. So every one of us know that the 4 is less than 8, right? Wait, 1 minute. 4 is less than 8. So every one of us know that 4 is less than 8. Agree? Agreed or not? 4 is less than 8. So if you apply log with base 2 on both sides for this inequality 4 less than 8, if you apply log with base 2, right side also apply log with base 2. So what is the value of log 4 here? Log 4 value is 2 and log 8 value is 3. So same we got here 4 less than 8 we consider, and we applied a log with the base greater than 1 for this inequality. Again we got 2 is less than 3. So sign of inequality here it is less than, and here also it is less than only. Okay, sign of the inequality is not changed here. Sign of the inequality is not changed here. Okay. So this is the first case. This is the first case where base is greater than 1. Now consider one more case where base is lying between 0 and 1. Consider one more case where base is lying between 0 and 1. Same example you can take 4 is less than 8. So 4 is less than 8 if you apply logarithm with base 1 by 2 on both sides. Log 4 with base 1 by 2 and log 8 with base 1 by 2. Now what is the sign of the inequality? Which one is greater? Log 4 is greater or log 8 is greater? First tell me the values of log 4 and log 8. What is the value of log 4 and log 8? Find out these two values and tell me in chat box. Find out these two values and tell me in chat box log 4 and log 8 value. So to find log 4 value, just consider log 4 base 1 by 2 as x. So converting it into exponential form, 4 will be equals to 1 by 2 whole power x. Okay, 1 by 2 whole power x. So now 4 is nothing but a 2 square, as well as this is a 2 power minus x. So bases are equal, so powers are also equal. X equals to minus 2. So the log 4 value is minus 2. Okay, log 4 value is minus 2. Log 8 with base 1 by 8, 1 by 2 value is log 8 with base 1 by 2. Consider it as x. Okay, logarithm with the base 1 by 2. Consider it as x. So 8 equals to 1 by 2 whole power x. Okay, 1 by 2 whole power x. Now 8 is nothing but a 2 cube. This is a 2 power minus x. So x equals to minus 3. Now which one is greater, minus 2 or minus 3? Out of minus 2 and minus 3, which one is greater? Obviously minus 2 is greater than minus 3. So what happened here? Initially we assumed 4 less than 8. After applying logarithm on both sides, what happened to this inequality? Log 4 is greater than log 8 we got. Minus 2 is greater than minus 3. Okay, understood the logic here? Understood the logic or not? So understood the logic, why we are changing the sign of inequality if base is lying between 0 and 1, and why we are not changing the sign of inequality if base is greater than 1. Okay, this is the logic behind that. Nothing is there. This is the logic. Okay, with the 4 is less than 8 example, it is I hope it is very clear why we are changing sign of inequality if base lying between 0 and 1. So let us solve some examples on this topic. Let us solve some examples on this topic. Okay, let us solve some examples on this topic. So first example is, so understood what is the method for solving logarithmic inequalities? Concept is simple. What is the concept? Base lying between 0 and 1, just change the sign of inequality, and base is greater than 1, same sign of inequality. This is the concept for solving logarithmic inequalities. And what is the method? What is the method for solving logarithmic inequalities? Method for solving logarithmic inequalities is, what is the method here? First, what step by step what we are doing while solving logarithmic inequalities? While solving logarithmic inequalities, step by step what we are doing here. First step is, while solving logarithmic inequalities, the first step is solve the inequality. So what is the first step? First step is solve the inequality. Okay. So first step is just to solve the inequality, and second step is, what is the second step? Find the domain. Find the domain. And what is the domain? What is the domain here? Domain is nothing but x values for which function is defined. Okay. What is the domain here? The value of x for which the function is defined. Set of x values. Set of x values for which the function is defined. That is nothing but a domain of the function. Okay, so what is the method here? First step is solve the inequality, find the domain, and step 3 is What is the step 3? Step 3 is take intersection of step 1 and step 2. Take intersection of step 1 and step 2. Okay. In step 1 you will get one interval, and step 2 you will get another interval. So step 3 is take interval which is common for step 1 and step 2. Okay. Take intersection part which is common for step 1 and step 2. Okay. Take interval which is common for step 1 and step 2. Clear? So this is a method for solving the logarithmic inequalities. If you have any doubt, you can ask me in chat box. Okay. If you have any doubts, you can ask me in chat box. Otherwise, we can move to the further questions based on these logarithmic inequalities. Based on these logarithmic inequalities, we will solve some questions. Okay. If you have any doubts, you can ask me in chat box. Otherwise, we can go to the questions. Concept is clear. Concept is clear or not? So concept is base lying between 0 and 1 will change the sign of inequality, and base greater than 1 no need to change the sign of inequality. What is the method for solving logarithmic inequalities? Method is just to solve the inequality, find the domain, and take a common part for step 1 and step 2. Okay, take a common interval for step 1 and step 2. Is it clear? Is it clear? So I hope it was clear. We can solve some questions on this logarithmic inequalities now. So first question is, first example is log 5x minus 1 base 1 by 3 greater than 0. So first example is, examples, first one is log 5x minus 1, log 5x minus 1 base 1 by 3 is greater than 0. How to solve this logarithmic inequality? Can anyone tell me how to solve this logarithmic inequality? Log 5x minus 1 to the base 1 by 3 greater than 0. Log 5x minus 1 to the base 1 by 3 greater than 0. How to solve this logarithm? So first step is, what is step 1? Step 1 is, what is the step 1 here? Step 1 is solve the inequality. How to solve this inequality? Since base 1 by 3, no, base is lying between 0 and 1. Base is lying between 0 and 1. What is the value of 1 by 3? What is the value of 1 by 3? 0.33 bar, right? So base is lying between 0 and 1. Since base is lying between 0 and 1, just change the sign of the inequality. So 5x minus 1 is greater than will become less than, and 1 by 3 whole power 0. 1 by 3 whole power 0. So 5x minus 1 is less than 1 by 3 whole power 0 is nothing but 1, and 5x is less than 2. So x is less than 2 by 5. Okay, clear? This is step 1. Log 5x minus 1 to the base 1 by 3 greater than 0. So 5x minus 1 is less than 1 by 3 whole power 0. Why we are changing the sign of inequality? Since base lying between 0 and 1. So 5x minus 1 is less than 1, 5x less than 2, x less than 2 by 5. And what is the step 2? Step 2 is find the domain. Find the domain of this logarithm. Find the domain of this logarithm. What is the domain of this logarithm? Domain of this logarithm is here this expression should be greater than 0. Okay, whatever the value will give here, that should be greater than 0. So 5x minus 1 should be greater than 0. So x should be greater than 1 by 5. So x should be greater than 1 by 5. Here x is less than 2 by 5. Now which one is greater, 1 by 5 or 2 by 5? Which one is greater, 1 by 5 is greater or 2 by 5 is greater? Obviously 2 by 5 is greater than 1 by 5. So for step 1 and step 2, if we take interval here, what 1 by 5, where it is located? 1 by 5 left of 2 by 5. So this is 1 by 5, and 2 by 5 is nothing but 2 times of 1 by 5, right? 2 by 5 is nothing but 2 times of 1 by 5. So it will be in right side of the number line. 1 by 5 will be left side of the number line. Now what is the intersection part? X less than 2 by 5 will be from minus infinity to 2 by 5. X greater than 1 by 5 will be from 1 by 5 to infinity. X greater than 1 by 5 is from 1 by 5 to infinity. So what is the common part for these two intervals? Common part for these two intervals is x belongs to 1 by 5 comma 2 by 5 open. So this is the answer for this question. Okay, this is the answer for this question. Logarithmic inequalities, first question. Logarithmic inequalities, first example. Log 5x minus 1 base 1 by 3. Step 1 and step 2. Third step is intersection of step 1 and step 2. So intersection of step 1 and step 2. So finally we got x belongs to 1 by 5 comma 2 by 5. Is my voice audible? Once check and tell me, is my voice is audible or not? Yes, my voice is audible. Okay, so clear. So let us see one more example on this logarithmic inequalities. One more example on this logarithmic inequalities. Let us see one more example on this logarithmic inequalities. Okay, so second example is log x square minus 5x plus 6. What is the second example here? Example number 2. Log x square minus 5x plus 6. X square minus 5x plus 6 base 0.5 or 1 by 2, we can consider it as 1 by 2, greater than minus 1, greater than minus 1. So once I try to solve this question in the chat box, once I try to solve this question in chat box and tell me the answer for this question. Once I try to solve this question. Log x square minus 5x plus 6 base 1 by 2 greater than minus 1. Try to solve this question. Let me drink some water. You try to solve this question and tell me the answer in chat box. Okay. So how to solve this question? What is the step 1 here? Step 1 is, what is the step 1? What is the step 1? Step 1 is solve the inequality first. So solve this inequality. How to solve this inequality? How to solve this inequality? Write exponential form. X square minus 5x plus 6. Since base is lying between 0 and 1, we have to change the sign of the inequality. So 1 by 2 whole power minus 1. So here x square minus 5x plus 6. What is 1 by 2 whole power minus 1? 1 by 2 whole power minus 1 is nothing but 1 by 1 by 2, which is 2. If we take it left side, minus 2 is less than 0. So x square minus 5x plus 4, okay, plus 4, x square minus 5x plus 4 is less than 0. X square minus 5x plus 4 is less than 0. So what are the roots here? We can factorize minus 5x to x minus 1 and x minus 4. So x minus 1 and x minus 4 is less than 0. X into x square minus 4x minus x minus 5x plus 4. This is the first step. So this is the first step of this question. Step 1 is x minus 1 into x minus 4 less than 0. What is the step 2? Step 2, we need to find the domain also. We need to take care of a domain. What is the domain for this? Domain for this is x square minus 5x. Domain means this value should be greater than 0. Okay, domain means this value should be greater than 0. X square minus 5x plus 6 should be greater than 0. So what are the factors here? Factors here are minus 6 and plus 1, right? So x minus 6 plus 1, can we take here minus 6 plus 1? No, we cannot take a minus 6 plus 1. Can we take minus 2 and minus 3 are the factors for this middle term? Yes, minus 2 and minus 3 are the factors we can take, minus 2 and minus 3. Okay, minus 2 and minus 3 we can take factors like that. So x square x minus 2 into x minus 3 greater than 0. X into x square minus 3x minus 2 x minus 5 plus 6. So this is step 1 and step 2. What is step 3? Step 3 is nothing but intersection of step 1 and step 2. What is the step 3? Intersection of step 1 and step 2. What is step 1? X minus 1 into x minus 4 less than 0. So what values we need here? We need 1 as well as we need 2 and we need 3 also, 4 also we need. So what is the interval x minus 1 into x minus 4 less than 0? By using Weyerhaeuser method, we can say 0 to 4 is the interval for x minus 1 into x minus 4 less than 0. 1 to 4 is the interval. For x minus 2 into x minus 3 greater than 0, what is the interval? What is the interval? So 2 and 3 we will plot here, plus, minus and plus. So from minus infinity to minus 2, from minus infinity to minus 2 and from 3 to infinity is the required interval for step 2. Step 1 interval is from 1 to 4 and step 2 interval is from minus infinity to 2 and from 3 to infinity. So what is the common part for these two intervals? Common part for these two intervals is x belongs to, common part for these two intervals is x belongs to 1 comma 2 union 3 comma 4. 1 comma 2 union 3 comma 4 is a intersection part for both step 1 and step 2. So the final answer for this question is x belongs to 1 comma 2 union 3 comma 4. Okay, clear with this question or not? Tell me once, tell me in chat box, is it clear or not? X belongs to open 1 comma 2 union 3 to 4. Clear? Yes, I hope it is clear. Yes, clear, sir. Yes. Yes. Ketan will for clear. Yes. So till now what we have seen with the constant base only we have seen, right? So first example with the constant base only we have seen. What is the first example? Base 1 by 3. Second example is the base 1 by 2. And here while discussing the concept also we have seen with the constant base only. Okay, with the constant base only till now we have solved questions. What if base is a variable base? What if the base is a variable base? What we will do if the base is variable base? What we will do if the base is variable base? Yes, we need to take two cases. So for base, variable base, logarithmic inequalities with variable base. So what is the next topic here? Next topic is, I'm writing here. Next topic is logarithmic inequalities. So what is the next topic here? Logarithmic inequalities with variable base, right? Logarithmic inequalities with variable base. So logarithmic inequalities with variable base. How to solve this type of question, logarithmic inequalities with variable base? How to solve this type of questions, logarithmic inequalities with variable base? We need to take two cases, right? We need to take two cases where base lying between 0 and 1 and base greater than 1. So two cases possible here for variable base. For variable base, two cases are possible. Logarithmic inequalities with variable base. Logarithmic inequalities with a variable base. So two cases are possible here. First case is base lying between 0 and 1. First case is base lying between 0 and 1. Second case is base greater than 1. Base greater than 1. So through a question we can see this concept here. So logarithmic inequalities with the variable base. Let me write one example question for you. So question is log of, for example, log x cube minus x square, log x cube minus x square minus 2x base x less than 3. Okay, this is the question. Log x cube minus x square, log x cube minus x square minus 2x base x less than 3. What is the solution for this question? How to solve this? How to solve this? So we need to take two cases. Step 1, while solving inequality. So what is the step 1 here? Step 1 is solve inequality. In step 1 again we will have two cases. So step 1 is solve inequality. Step 1 is solve inequality. In step 1 itself we will have two cases. First case is base lying between 0 and 1. Base lying between 0 and 1. Step 1 first case is base lying between 0 and 1. If base is lying between 0 and 1, what we will do? What we will do if base is lying between 0 and 1? If base is lying between 0 and 1, we will change the sign of the inequality. So we will change the sign of the inequality. So x cube minus x square, x cube minus x square minus 2x is greater than x cube. Okay. So x cube minus x square minus 2x is greater than x cube. Why we are changing here? Base is lying between 0 and 1 case we are considering. So both sides x cube and x cube cancel. If you multiply this inequality with minus x square plus 2x will be less than 0. So x into x plus 2 is less than 0. So by using the Weyerhaeuser method we can find the solution for this inequality. X into x minus 2 less than 0. What are the critical points here? 0 is one critical point and minus 2 is another critical point, right? So 0 is one critical point and minus 2 is another critical point. So first plot minus 2. First plot minus 2 here and 0 is another critical point. So less than 0 is less than 0, right? So open interval. Here circle, here also circle between minus 2 and 0. So x belongs to minus 2 to 0, but we are considering x between 0 and 1. We are considering what is the case we are taking here? X should lie between 0 and 1. The case we are considering here, it is x should lie between 0 and 1. And what is the answer we got? X lying between minus 2 and 0. x lying between -2 and 0, but the case we are considering is x lying between 0 and 1. Both the cases need to satisfy. These both cases need to satisfy here. So x should lie between 0 and 1, as well as x should lie between 0 and 1, as well as x should lie between -2 and 0. So what is the common part for these two intervals? There is no value which is satisfying both the conditions. So x belongs to 5 in first case. In first case, we don't get any solution here. In first case, we didn't get any solution here. So second case is, what is the second case? Second case, consider base as greater than 1. Consider base greater than 1. Base greater than 1 means, what is the case here? X should be greater than 1. Base greater than 1 means nothing but x greater than 1. So if we consider this case x greater than 1, sign of inequality will remain same. So by converting it to exponential form, see who found this x? Very irritating to write here, x in notepad. Okay, so x cube minus x square, x cube minus x square minus 2x, x cube minus x square minus 2x. So less than will be less than only, less than will be less than only, and here x cube will write, x cube and x cube cancel on both sides. So if you multiply this inequality with minus, so x of x minus 2, x of x minus 2 will be greater than 0. So x of x minus 2 greater than 0, what is the interval you'll get here? -2 and 0. Sorry, 1 minute. Multiplied with minus, no? So x square plus 2x, right? X into x plus 2. Yes, x into x plus 2. X into x plus 2. So minus 2 is one root and 0 is another root. If you by applying Weaver method from 0 to infinity as well as from minus infinity to minus 2, we got the answer here. From minus infinity to minus 2 and 0 to infinity. But what is the case we are considering here? X should be greater than 1. X should be greater than 1 and x also should satisfy from minus infinity to minus 2 as well as from 0 to infinity. So 0 to infinity and from 1 to infinity. What is the common part for these two intervals? Common part for these two intervals is x should belongs to 1 to infinity. X belongs to 1 to infinity. So first case we have considered x is greater than 1 and we got x is a number between minus infinity and minus 2 to 0 to infinity, and the case which we considered is from 1 to infinity. So common part for these two intervals is from 1 to infinity. Common part is from 1 to infinity. Okay, yes, 1 to infinity. Yes, you are correct, Kirtan. So what is the step 1 completed? Till now we have done step 1 only. Okay, so step 1 only till now we have done. What is the answer for step 1? 1 to infinity is the answer for step 1. Now step 2 we need to do. For step 2 we need to find the domain. For step 2 we need to find the domain. What is the domain? X cube minus x square minus 2x. So step 2 is, what is step 2 here? Step 1 only till now step 1 only completed. Now we are going to step 2 for finding domain, because x value also should satisfy now. So for step 2 we are going now. So step 2, domain should be greater than 0. Domain should be greater than 0. So x cube minus x square minus 2x. X cube minus x square, x cube minus x square minus 2x should be greater than 0. x cube minus x square minus 2x should be greater than 0. If you take x common, what will remain? X square will remain, minus x will remain, minus 2 will remain. What are the factors for this quadratic equation? Factors for this quadratic equation are x into minus 2 and plus 1 we can take, right? Minus 2 and plus 1 we can take. So x minus 2 and x plus 1 greater than 0. Okay? Yes. X into x minus 2 into x plus 1 greater than 0. X into x square plus x minus 2x and minus 2. So x into x minus 2 into x plus 1 greater than 0. Step 2 I am writing here. What are the critical points for step 2? Critical points for step 2 are minus 1 is one critical point, 0 is another critical point, and 2 is another critical point. So from 2 to infinity, positive, here negative, positive, and negative. So positive interval you need to take, right? So from 0 to infinity and from minus 1 to 0. This is step 2. Step 2 is from minus 1 to 0 and from 2 to infinity. And what is the step 1 here? Here you can see. Step 1 is from 1 to infinity. Step 1 is from 1 to infinity. So what is the common part for these two intervals? What is the common part for these two intervals? Common part for step 1 and step 2. So what is the step 3? Step 3 is basically intersection part of step 1 and step 2. So what is the final answer here? X belongs to 2 to infinity is the final answer for this question. Okay. So x belongs to 2 to infinity is the final answer for this question. So this is how we will solve logarithmic inequalities with variable base. This is how we will solve these logarithmic inequalities with a variable base and a constant base. So with this logarithmic inequalities, the concept completed. So you can do any example question from any material based on this topic. Okay. Any material, any question you can do from logarithmic inequalities, and the logarithm full chapter we have completed, full topic we have completed. Shall we see PYQs now? So we have started our stream. How many minutes back we have started? So 1 or 7 minutes, right? I can see chat box here. Until now, any doubts you can ask me. Yes. Yes, clear, sir. Take case. Yes, Saraswati. Hi, sir. Hi, yes, hi. Kirtan Wilford. On to infinity. Yes, correct. Okay. So, shall we solve some examples? Some example PYQs here. Shall we solve some PYQs? Respond in chat box quickly so that without wasting your time, I'll go to PYQs. JEE main PYQs are there based on this concept. So, tell me in chat box whether we have to go or not. Quickly. Respond in chat box. Respond in chat box quickly. Yes, do PYQ. Do PYQ. Yes, okay. So first PYQ. First PYQ of this session within, yes, we have time. Still we have time. Okay, so PYQs we'll do now. Okay, some JEE PYQ. Some JEE PYQs. Okay. See, writing pad is not working properly. Okay, so don't mind. I'll clear it tomorrow. Okay. So some JEE PYQs. So first one is that is just 96. Okay. So some JEE PYQs. So first one is The integer k for which the inequality, first question, the integer k. So first PYQ, is the integer k for which the inequality x square minus 2 times of 3k minus 1 into x plus 8k square minus 7 plus 8k square minus 7 greater than 0 is valid for every x belongs to R. For all x belongs to R, for every real value of x, the integer k for which this expression is greater than 0. So tell me how to solve this question. Tell me how to solve this question in chat box so that we can solve. We can start solving this question. Okay. The integer k for which this expression is greater than 0. So if you see carefully, this is a quadratic equation, right? If you see carefully, this is a quadratic equation. If you see carefully, this is a quadratic equation. So quadratic equation, when it will be greater than 0? Quadratic equation, when it will be greater than 0, always greater than 0. For all real values of x, this expression is greater than 0. So only two conditions we have. What is the first condition? First condition is a should be greater than 0 and d should be less than 0. Okay, so a should be greater than 0 and d less than 0. Already here a is 1. So that 1 is greater than 0. Already that condition is satisfied. So d should be less than 0. D of this quadratic equation, discriminant of this quadratic equation should be less than 0. Discriminant of this quadratic equation should be less than 0. So what is the discriminant of this equation? Discriminant of this equation is b square. B square means this whole square, minus 2 whole square, which is 4, as well as 3k minus 1 whole square. Okay, so 4 times of 3k minus 1 whole square, this is b square minus 4 times of b square minus 4 ac. A value is 1, c value is 8k square minus 7. So d is less than 0. This is b square minus 4ac. So here minus 2 whole square, which is 4, 3k minus 1 whole square minus 4 ac, b square minus 4ac is less than 0. So 4 we can move to the right side of inequality. So what will remain in left side? Here 9k square will remain. 9k square minus 6k. 9k square minus 6k plus 1 minus 8k square minus into minus plus 7 is less than 0. So 9k square minus 8 square k square is k square minus 6k. 7 plus 1 is 8 less than 0. Okay, less than 0. So k square minus 6k plus 8. What are the roots here? How to factorize middle term? K square minus 2k minus 4k. We can split middle term like minus 2k and minus 4k should be less than 0. So k minus 2, k of k minus 2 and minus 4 of k minus 2, which is k minus 4. So k minus 2 into k minus 4 less than 0. What is the solution for this k minus 2 into k minus 4 less than 0 by using the wavy curve method? We have already seen a lot of questions. So 2 is one root and 4 is one root. 2 is one root and 4 is one root. Here plus, here minus, and here plus. So less than 0 interval is from 2 to 4. And now what is the interval between 2 to 4? What is the integer between 2 to 4? Question is the integer value k, the integer k for which this expression is always greater than 0. What is the integer between 2 and 4? Integer between 2 and 4 is 3. Yes, obviously integer between 2 and 4 is 3. So k should be equals to 3. So this is the answer for this question. This is answer for this question, and this is 2021 mains PYQ. So this is 2021 PYQ. Okay. So this is a 2021 mains PYQ. The integer k which is satisfying this equation is 3. So shall we see one more question? Shall we see one more question? Second question, second PYQ. Quickly respond in chat box. Shall we see one more PYQ on this logarithmic inequalities where we will apply this logarithm? Logarithm and basic maths. I'm including logarithm and basic maths. Actually, this is a basic maths PYQ. Basic maths inequality note point I have taught you. So this is based on our second lecture. So first PYQ is based on our second session. Now we are going to see another PYQ, which is the product of all solutions of the equation. Second question is, okay, okay, 1 minute. The product of is lagging. The product of all solutions. So the product of all solutions of equation the product of all solutions of equation e power log e power log e power 5 times of log x square. 1 minute. E power 5 times log x square plus 3 e power 5 times 1 minute. I'll write one more time this equation. So it was very much lagging here. Please don't mind, it is lagging. Yes, okay. So the product of all solutions of the equation e power 5 times of log x e power 5 times of log x with base e whole square e power 5 times of log x with base e whole square plus 3 equals to x power 8 equals to x power 8 and x should be greater than 0. Okay, tell me the answer for this PYQ. So this is 2025 January 22nd first shift. This is 2025 January first shift, January 2022 first shift, January 22 first shift. So this is 2025 PYQ. JEE Main 2025 PYQ. Okay. The product of all solutions of the equation. The product of all solutions of the equation e power 5 times of log x base e whole square plus 3 equals to x power 8. So how to solve this question? What is the approach? What is the approach here? So whenever you see power here, whenever you see power or multiplication, whenever you see the power or the terms which are in multiplication, just apply log on both sides. Okay, just apply log on both sides. You'll see the magic after applying log on both sides here. So if you apply log on both sides, I'm applying log on both sides. So log e power 5 times of log x base e whole square plus 3 to the base e equals to log x power 8 base e. Okay, so what is log e base e? Here power we can write before the log. So by using the logarithmic properties, this power we can write before the log. So 5 times of this log x base e whole square plus 3 equals to x power, see 8 also we can write before the log. Since it is in power, by using properties of log, we can write 8 before the log. Now consider this log x for log x base e as a t for sometimes. So consider this log x base e as a t. So the equation will become 5t square, 5t square. This one if I move left side, minus 8t plus 3 equals to 0. So what is this equation? This is a quadratic equation in t. So this is a quadratic equation in t. This is a quadratic equation in t. Let us assume t1 and t2 as zeros of this quadratic equation. Let us assume t1 and t2 as zeros of this quadratic equation. Okay, let us assume t1 and t2 as roots of this quadratic equation. Now they are asking product, right? See the term here, product. They are asking product of all the solutions. So to get product of all the solutions, we need to take a sum here. What is the sum of roots t1 plus t2? What is the sum of roots t1 plus t2? Sum of the roots is, what is sum of roots? Sum of roots is nothing but b by a. Sum of roots is nothing but minus b by a. Sum of the roots is nothing but minus b by a, which is 8 by 5. Sum of the roots is 8 by 5. And what is the exponential form of this? X equals to e power t. Okay, x equals to e power t is exponential form. But what is the t1? T1 is nothing but log x1, right? T1 is nothing but log x1 and T2 is nothing but log x2. T2 is nothing but log x2. Okay, so T1 is log x1 and T2 is log x2 equals to 8 by 5. What is log m plus log n formula? Log m plus log n formula is log mn. Log mn. So log x1 plus x2. Log x1 plus log x1 plus log x2 is log x1 x2, which is equals to 8 by 5. So what is x1 x2 value here from here? What is the value of x1 x2 from here? X1 x2 value will be equals to, what is the value of x1 and x2 from here? X1 x2 value will be equals to 8 by e power 8 by 5. Okay. So what is the value of x1 and x2? X1 x2 value is equals to e power 8 by 5. X1 x2 x1 x2 equals to e power 8 by 5. So this is the answer for this question. Okay, clear with this PYQ? So product of all solutions of the equation. product of all solutions of this equation. Just whenever you see power or multiplication, just apply log on both sides. Okay, if it is in power, it will come before the log. If it is in multiplication, it will be split into addition. Okay, logarithm, what logarithm actually it will do, it will convert complex multiplication to simpler additions. So the work of logarithm is to convert the complex multiplications to simple additions. So product of all solutions, we got x1 and x2 are the equations of this equation. So x1 x2 are the solutions of this equation. So product of solutions is e power 8 by 5. So this is the final answer. X1 x2 equals to e power 8 by 5 is the final answer for this question. Okay, so one more PYQ we will see. Second question, okay, product of all solutions, and the first question is integer k for which this expression is greater than 0. One more question we will see, PYQ. So third PYQ on logarithms is actually it is mixed with quadratic equation also. So in quadratic equation chapter we will see that question. Okay, one more question I thought to discuss here. One more question I thought to discuss, but it is from quadratic equation mixed chapter. Okay, quadratic equation also mixed here. So that's it for today. Okay, so quadratic also mixed, still more PYQs are there. Let me give you one practice question based on logarithmic inequality with variable base. Try to solve this question for homework. Okay, try to solve this question, logarithmic inequalities with variable base. Logarithmic inequality with variable base. Try to solve this question. Try to solve this question as homework. X square minus 5x plus 6 log of x square minus 5x plus 6 and base 2x log x square minus 5x plus 6 base 2x is less than 1. So try to solve this question as a homework. Okay, try to solve this question as homework. Log x square minus 5x plus 6 log x square minus 5x plus 6 base 2x is less than 1. Logarithmic inequality with variable base. Logarithmic inequality with variable base. Okay, try to solve this question. Try to solve this question as a homework. Okay, so try to solve this question as a homework. So today what we have discussed, once see this recap for today what we have discussed. Small concept only, but very important while preparing for JEE Mains. Okay, small concept only we have discussed. Okay, so commonly used base. Shall we see logarithms from starting onwards? So full logarithms we have completed today. Logarithms fully we have completed today. Okay, so logarithms, we have started from here. And what input we can give for the logarithm, what are the values we can give as input for the logarithm, and conditions for base. So base should be greater than 0 and not equals to 1 for the logarithm. Logarithm base should be greater than 0 and not equals to 1. Only positive values we can give as input for the logarithm. Okay, only positive values we can give as input for the logarithm, and we should read this expression log x with base a. This log x with base a, we should read it as log of x with base a. Log of x with base a, and what we have seen further, how to convert this exponential function to logarithmic function we have seen. How to convert exponential function to logarithmic function we have seen. So these are the examples for converting the exponential function to logarithmic function. Okay, and a power x equals to n. Suppose if this is exponential function, a is called base, x is called exponent, index or power, and n is the value of the exponential function. Okay, so what logarithm will do? Logarithm will actually convert the complex multiplications to simple additions. Okay, wherever there is a rapid growth or a rapid decay applications, we will use this logarithm. So, for example, rapid growth in the bacteria and the rapid decay of the bacteria. In that scenario, so we will use the concept of logarithm. Okay, for calculating at what rate the bacteria is growing and at what rate the bacteria is decreasing. Okay, so and log 1024 value, log 64 value, log 100 value, and what is the domain and range of the logarithm? Domain of the logarithm is from 0 to infinity, and the range of the logarithm is from minus infinity to infinity. So properties of logarithm also we have seen. So how many properties we have? Nine properties. We have nine properties of logarithms we have seen, and then we came to the equation of log. In equation of log, we have seen three questions: how to solve the logarithmic equations, and one PYQ also we have seen in that. So today we have started with the commonly used base in this lecture. Particularly in lecture 4, we have started with the commonly used base. So 10 and E are the commonly used base, and this is very important. Okay, logarithm logarithm with the base E can also be written as logarithm with the base E. Logarithm with the base E can also be written as shortly ln x. So this is very important. Log x with the base E can be written as shortly ln x. Okay. So common logarithm, natural logarithm, and the graph of the logarithm also we have seen. If base is lying between 0 and 1, graph, okay, if base is lying between 0 and 1, logarithm function will behave as a decreasing function. And if base is greater than 1, this logarithm will behave as a increasing function. If base is between 0 and 1, the logarithm will behave as a decreasing function, and base greater than 1, it will behave as an increasing function. And if we apply decreasing function for an inequality, sign of the inequality will be changed. Okay, obviously we have seen the questions also based on that point. And logarithmic inequalities, base lying between 0 and 1 is the first case, and the base is greater than 1 is the second case. So method for solving logarithmic inequality also, three steps will be there. First step is solve the inequality, second step is find the domain, and take intersection part for step 1 and step 2. Okay, so I have planned to do some more PYQs on this topic, but the video length is becoming video is becoming very lengthy, so I'm trying to stop this video. Okay, now itself, since it is becoming lengthy, and my system is also lagging. Okay, so logarithmic logarithmic inequalities, one question we have seen, and two JEE PYQs only we have seen in today's class. Okay, that's it for today. That's it for today. If you have any doubts, you can ask me in chat box. Okay, is it clear till now? Is it clear or not till now? So let me stop sharing my screen first here. So answer for this homework question I'll reveal tomorrow. Okay, answer for this homework question I'll reveal it tomorrow. No, don't worry. Okay, tomorrow also we can have live. So let me stop my screen. Let me stop sharing my screen. So I have stopped sharing the screen. Yes, you can check tomorrow, Kirtan. So that's it for today, guys. Hope you have understood all the concepts and the PYQs also. I hope you have understood everything. So that's it. Bye. Bye, guys. Bye, bye, bye. Bye. Good night, everyone. Bye. Good night. Good night. Good night. Let me end this live stream. So bye. Bye. That's it for today's class. Okay. Good night. Good night. Good night.